Sam's playing a game. She uses a ball, a cup, and a spinner. The random variable x represents the number the spinner lands on its spun, and the probability distribution is given in this table. Now, we don't know what A, B, and C, D are, but we do know that they're going to add to give 1. So to play the game, the spinner is spun to obtain a value of x, and then Tizam stands x centimeters from the cup and tries to throw the ball in. The event S represents the event that Tizam successfully throws the ball into the cup. And to model the game, Tizam assumes the probability of S given x equals little x is k over x. So the further she stands away, the lower the probability is. However, the probability of S and x equals x should be the same whatever value of x is obtained from the spinner using Tizam's model. So because there's going to be a lower probability of getting it in when she's 100 centimeters away, then there's going to be a higher chance of spinning 100. We're going to make it so it's, I don't want to call it a fair game, but just, yeah, we need to make it so the probabilities overall are the same of scoring and getting a particular value for x. We're asked to show that C is equal to 8 over 5b. Right, well, let's work out some probabilities. Probability of getting, scoring and getting x equals, well, because I want to relate C and B together, let's go with that. So x equals 50. And the probability of scoring, we've already seen, when she gets 50 is k over x. So it's going to be k over 50. And the probability of getting 50 is b. Meanwhile, the probability of scoring and getting x equals 80, that is going to be k over 80 for scoring times by c for actually getting 80. So I'm timesing those two together. And it must be that these two are the same because we're told that it is the same whatever. We don't know what the value is. That's important to say, but they are the same. So therefore, k over 80 times c is equal to k over 50 times b. I can cancel out the k's. I can times through by 10. And then I can rearrange to make c the subject, and I will get c equals 8 over 5b. Then asked to find the probability distribution of x. So I've got c in terms of b. What if I got a and d in terms of b as well? Then we could add them all up, set it equal to 1 and work out b. So the probability of s and x equaling 100, let's do that one next, is going to be k over 100 times d. But remember, that is again equal to k over 50 times b from before. It's the same idea throughout, should be the same. And therefore, I can again, maybe I'll just do this on another line now. I can write down d over 10 equals b over 5. So d is going to equal 2b. Right, and I've just got one more. Probability of s and x equaling 20 is equal to k over 20 times a. And again, that is equal to k over 50 times b. So a over 2 is going to equal b over 5, and a is going to be 2/5 b. So a plus b plus c plus d equals 1. Therefore, 2/5 b plus b plus 8/5 b plus 2b must equal 1. That gives 5b equals 1, so b is equal to a fifth. And from that we can get all the rest of them, and I'm just going to go straight for the table now. X, probability x equals little x, then 20, let me draw a line, make it a bit neater. 20, 50, 80, 100. Just worked out this one as 1/5. For A, it's 2/5 times B, so it's going to be 2 25ths. C was 8/5, so it's 8 25ths. And then for D, it's 2B, so it's going to be 2/5. So as you can see, that is the highest probability because it has the lowest chance of actually going in. And it will follow that this is true. So that is our distribution. Nav tries a large number of times to throw the ball into the cup from a distance of 100 centimeters, and he successfully gets it in 30% of the time. State giving a reason why Tizam's model of the game is not suitable to describe Nav playing the game for all values of x. So what we just have been given is the probability of scoring given that x equals 100 is equal to 0.3 for Nav. But we actually know that that is then k over x. So therefore, k over 100 equals 0.3 and k equals 30. But then the probability of scoring given that x equals 20, if we're closer, is going to equal 30 over 20, which is greater than 1. And that's the problem here. So not possible. You can't have a probability greater than 1. And therefore, model is not suitable. Okay, bit of a different question's got to be said, but I hope that makes sense. Just work through, finding everything in terms of B, getting the distribution, and then just like working out or using the probability to get K and showing that it's just not possible because we'd get a probability greater than 1 for if 20 is spun on a spinner.